So we have got a flagpole, and it's 15 meters high, or 15 feet, I guess. And we've got a man who is 6 feet tall. And that on the top of this light post is a light, and it's going to create a shadow for this guy. So I'm just going to draw in the guy here. And his head, shadow head, is going to be right here. And he's moving. So there are variables that are changing here. His height is definitely not changing, so that's fixed. I'm going to label that as 6. There is this distance right here that's changing, which is the distance he's moving away from the pole, and we're told that he's moving at a rate of 5 feet per second. Was it per second? I'm just double checking here. It was kind of lost track of which question I'm doing here. 5 feet per second, yeah, sorry. So we know that x is changing at 5 feet per second. Now the trick with this question is there's a y value changing here as well. And actually, that's not right. I'm going to make that y is changing, but I'm going to label this as my y. And the reason I'm going to label this as my y here, all the way to here, is because I want to measure how fast this top of his shadow is changing with respect to something that's not changing, the lamppost. If I label this one this thing right here, I'm going to measure how fast it's changing with respect to the guy, and he's moving too. So I want to measure it against something that's fixed. So my question is, how fast is the shadow moving? That's the part that I don't know. And I want to ask that when the man is, how far away is he? He is 40 feet from the pole. All right, so I do still need to assign a variable to this, but instead of introducing a new variable, I'm going to call this distance y minus x. It's just the difference between the entire distance minus the distance the guy has walked. So to establish a relationship between these, I'm going to use the similar triangles. So 15 compares to 6, and on the big triangle, y, which is all of this, compared to on the small triangle, which is this distance right here, which is y minus x. That's a pretty complicated relationship, especially if I know I've got to take the derivative. So I'm actually going to cross multiply to get rid of the fraction. Multiply the y 15 through. Collect the y's on one side and the x's on the other, and then reduce the fraction. So that's 15/9 over x, which I can write as 5/3 x. So now I'm going to take the derivative, and with respect to time. So on the left hand side, it's not dx, it's dy by dt is equal to 5/3 dx by dt. And the funny thing is that we didn't really actually need this information at all, because there is no x that shows up in this equation. So we can keep going. Dy by dt is 5/3 times dx by dt, which we're told is 5. And that means that my final answer is 25/3 feet per second, because y is measured in feet and time is measured in seconds.